All right, guys, today in class we talked about solving one-step equations. So what is a one-step equation? And a one-step equation means you only have to perform one mathematical operation to solve it. So we can add, subtract, multiply, or divide to solve a one-step equation. So some examples might be a plus 34 equals 72. Notice we just have to do the addition to solve the problem, so it's a one-step equation. 3b equals 18. And this one, we're taking 3 times b, that's why they're written as a coefficient in a variable, equals 18. So we have one step, that's our multiplication to solve. H minus 9 equals 66, that's our subtraction. And then y divided by 7 equals 14. Remember that the fraction bar does mean division. So those are all examples of what a one-step equation looks like. So to solve a one-step equation, we're going to be using inverse operations. And inverse operations are operations that undo each other. So they're just opposites, kind of. So for example, addition, the inverse would be subtraction. So if I add 2, the inverse would be to subtract 2. For subtraction, it would be addition. If I'm subtracting 4, the inverse or the opposite would be to add 4. Multiplication, the inverse is division. Okay, so if I'm multiplying by 4, to undo that, I would divide by 4. And then therefore, division, it would be multiplication. So if we're dividing by 6, to undo that, we would multiply by 6. So when we're solving a one-step equation, our goal for the entire thing is to get that variable all by itself. We want to get the variable by itself because then we'll have the solution to the equation. So first off, what you're going to do is you're going to determine what inverse operation that the equation requires. If it's a multiplication problem, we're going to be using division as our inverse. If it's addition, we're going to be using subtraction as our inverse. Okay, after you figure out that inverse operation, you're going to perform that inverse operation to both, and that is huge, and that's a big deal. We're going to have to do it to both sides of the equation. Now, equation means that both sides are equal, so whatever we do to one side, we have to do to the other side. Now, also, we're going to write our answer in the form of variable equals the solution. So the variable is going to be on the left, and we're going to set it equal to our solution on the right. So let's take a look at some of these examples. Now, remember, we talked in class about how you can probably just look at these and know the answer. And that's fine. That's great. That's a great way to check your work. However, when we're solving a one-step equation, this is the building block for what we're going to do for two-step equations. This is the building block for what we're going to do for multi-step equations. So the system, the way that you solve the problem is the most important thing. Okay, so as we're working out these problems, the first thing that we're going to do is we're going to draw a line through the equal sign. And the reason that we're going to do that is so that we know whatever we do on this side of the equal sign, we have to do over here on this side as well to keep our equation balanced, to keep it equal on both sides. So I'm looking at this side, and here's my variable. We're solving for t, and we have plus 7. We're going to use the inverse of that, and the inverse of plus is subtraction. And so we want to cancel out the plus 7, so we're going to subtract 7. So whatever we do on the left, we have to come over here on this side of our equation and do the exact same thing. So if I'm subtracting 7 here, I'm going to subtract 7 here as well. Now, we have a plus 7 and a minus 7, and they cancel each other out, and we're left with just a t. That's what we wanted. Remember, we want to get that variable all by itself. And then over here on this side, we're just going to do 21 minus 7. 21 minus 7 gives us a 14. So our solution is t equals 14. Okay, so let's take a look at number 2. Again, the very first thing we're going to do is draw a line through our equal sign. Whatever I do on the left, I must have go over here to the right and keep my equation balanced and keep it equal. So we have g minus 6 equals 40. So the inverse operation that we're going to use is addition because we want to cancel out this minus 6. So to cancel out my minus 6, I'm going to use plus 6. Okay. Whatever I do on this side, I've got to come over here and do the exact same thing. So I'm going to add 6. Now, my minus 6 and my plus 6, they cancel each other out, and I'm left with just my g equals. And then over here we have 40 plus 6, and we get 46. So my final answer is g equals 46. Okay. Now, let's take a look at number 3. Number 3, we have 8n equals 32. First thing we're going to do is draw that line through the equal sign to remind us whatever we do on one side, we have to come over here and we have to do on the other side. So I have 8n. We know that when we have a coefficient right next to a variable, that means multiplication. So to undo my multiplication, I'm going to divide by 8. Okay, so the opposite of multiply by 8 would be divide by 8. Whatever I do on this side, I've got to come over here and do the exact same thing on this side. So I'm going to divide by 8 on this side as well. Here we have a times by 8 and a divide by 8, and those are going to cancel each other out, and we're going to be left with just an n. Then over here, we're going to take 32 divided by 8, and we get 4. So our final solution is n equals 4. Okay. All right, last one we're going to do all together. Let's take a look at k divided by 9. For k divided by 9, we're going to start by putting our line through the equal sign, and then we're going to determine our inverse operation. So the opposite of dividing by 9 is to multiply by 9. Whatever I do on this side, I've got to come over here and do the exact same thing on the other side. So I have divide by 9 times by 9. So over here, I'm going to times by 9. My divide by 9 and my times by 9, those are inverses, they're opposites, they cancel, and I'm left with just my k. And over here on this side, we have 11 times 9, and we get 99. So our solution is k equals 99.